Okay, so worded problems, applications of simultaneous equations. This question involves two children. The sum of their ages is 17 and their difference is 5. Kara and Ben. Kara is the older of the sister of Ben, and work out their ages. So you've got two variables, such as the ages of the kids. So you have Kara, who is the older sister. The drawing, you don't have to do the drawing, but I'm just making it a bit more visual. Okay, so we're going to call Kara and Ben. So we've got our two variables, K and B. Now, having a look at the question, we're going to try and set up two simultaneous equations. The first one, it says sum. Okay, it tells you to add. Okay, to sum means to add. The difference means to take away, but it actually means to take away the smaller number from the bigger number. So we're going to get a K minus B equation. Okay, so the sum of the ages of two children is 17. So we can say that one equation will be K plus B equals 5. Sorry, looking at the wrong number, 17. Okay, now the difference of their ages, which is K take away B, alright, that's whatever their ages are, it's K take away B is 5. Okay, we've got the two equations now. You might notice we've got positive K here and positive K here. If we take away one from the other, we can eliminate. So let's do that simultaneous equation. Okay, they're both neither of them have a variable on their own, so there's no advantage to substituting it in. Although you could change it around to do that. It's easier to just do it like this. So K minus K cancels out. Now B, take away negative B, and 17 take away 5. B, take away negative B. When we take away a negative number, it becomes a plus. We end up with 2B, and 17 minus 5 is 12. Okay, so working that through, we have B equals 6. Okay, so that tells us that Ben is 6 years old. Okay, either of these will work. You could substitute this B back into the equation. Let's do equation. Sorry, we should have called this equation 1 and equation 2 because we sub into. Oops. Let's do equation 1. Doesn't really matter. So K plus 6 equals 17. You work that through, and you're going to get K equals. You take away 6 from both sides, 11. All right, so we can tell that Ben is 6 and K is 11. You can check that using the other equation. K minus B equals 5. 11 minus 6 equals 5. Okay, so that's a simple elimination method worded question. Now, hi guys, I might have experienced a bit of a blip there when I transferred the question over. There were some errors, so this is the actual question. So let's start out by defining our variables. D is the cost of a daffodil. Okay, so we're talking about costs. John buys 3 and Julia buys 4. Cost of a daffodil, sorry, 1 daffodil. P is equal to the cost of a petunia. Okay, so let's have a look at each person's situation. John, he buys 3 daffodils. Okay, that's for the cost. That's the cost of the daffodils he buys. It's 3 times the amount that one is, plus 5 petunias, and that in total that is $25. Okay, 3 daffodils and 5 petunias is $25. Now Julia, she buys 4 daffodils and 3 petunias, which the question says is $26. Okay, so we've got two simultaneous equations here. Sorry, I've set a pair of simultaneous equations. There's nothing we can immediately eliminate straight away. So what we're going to do is we're going to try and multiply each equation by something to give us something to eliminate. So I'm going to use the D's. I'm going to use these ones because 3 and 4 are smaller numbers than 5 and 3. The lowest common multiple, just write this out. The lowest common multiple of 3 and 4 is equal to 3 times 4 is equal to 12. Okay, so I'm going to make those both into 12Ds. Okay, now to do that, I have to multiply this by 4. I have to multiply this by 3. Okay, so we end up calling this equation 1, equation 2. I might just move this over about that. I'll see if we can move it up a bit. And what we're going to do is we're going to say we're going to multiply this equation by 4, okay, because that'll give us 12Ds. And we're going to multiply this by 3, because that'll give us 12Ds here. You rewrite it, and you get 12D plus 20P, because 5 times 4 is 20, equals 25 times 4 is 100. Okay, same thing for the second line. 4D times 3 is 12D, plus 3P times 3 is 9P, equals 26 times 3. Let me just get my calculator out. 78. Okay, and we've got two new equations, 3 and 4. Okay, we can now use our elimination method to get rid of the D's. So let's put a line. We're going to take these away, because 12D take away 12D eliminates the D's. 20P take away 9P, and 100 take away 78. So 20 take away 9 is going to obviously give me 11P, and 100 take away 78 is equal to 22. Okay, 11 divided by 11P equals 2. Okay, so petunias are $2. It's a dollar amount in this. So to find daffodils, okay, sub back in, sub into any of these equations will work, but 1 or 2 is probably easier. Equation 1, and to find D. So 3D plus 5 times 2 is 25. Okay, that's my equation 1 with the P substituted for 2. Put a highlight there, that goes there. Okay, so let's work that through. 3D plus 10 equals 25. Take away 10 from both sides. 3D equals 15, and divide by 3, that cancels out and becomes 5. Okay, so daffodils are $5. Now, just a couple of notes on these. You can obviously in tests and real life situations, you're not going to get answers. A way to check that you're getting these right, you sort of think about if you're getting fractions, say for something like amounts of things, you know, like funky fractions. You get a funky fraction in any of these, you're probably doing something wrong. Obviously, you can get decimals in amounts of dollars, but yeah, whole number amounts are normal in these sort of questions. So just be careful of that. You've got a variety of equations to sub back into to check your answers, and you can work, if you've got $2 and $5, you can work back to see whether these equations are all true, which will give you the answer. I'm going to stop there. Sorry for scrolling up and down like that. Don't forget to like and subscribe.